In this video clip, I'll talk about backpropagation neural network. That will be like the one that we transform in the general term instead of using the MLP or the multi-layer perceptron. The backpropagation neural network is one kind of the multi-layer perceptron. Uh, the multi-layer perceptron is the term that we use like many layers, but backpropagation is a term that we use to tell other people that we will train this network using the backpropagation. Before we can talk about other part, we have to use the forward pass first and the notation that we will use. So in this video clip, you can see that we will use the input hidden and output layer. We separate it, and this one is the input, this one is the output, and this is the hidden layer. So we have a link from input to hidden, and hidden to output. And we use the same one, P1, P2, and P3, and we use it like the one that we trained in exclusive OR in the previous video clips. So you can see that we have the link that we transform, right? Can you remember? The P3 is the file output, and P1 and P2 as a link to P3, and P1 and P2 get the input from input layer. Okay. So you can see that now we have 3 layers. Normally, we use the TLN, the threshold linear neuron, for hidden and output. But this time we will change it to, because it's a backpropagation, the TLN is very difficult to be trained, right? Because we must use the if, so we'll use the sigmoid instead of the TLN. So you can see now we've used sigmoid function or the sigmoid node instead of the TLN. And in this pass, we will use just only the forward pass. The forward is the part that we like feed the input from the input side, and we call it the forward pass. We'll feed the input from input to hidden, and we'll calculate the hidden to output. So in our forward pass, we'll have some notation like this. We will use it the same way as we did before, that we have the input from the input layer, that we will use C to be the output in hidden layer. C comes from w.x, or summation of w from I input to h hidden times the activation or the signal function from x. But the signal function from x, we will pass it through the activation function, through the signal function. So we sum it from I to n. Okay, so this one is the part that we will pass the input through the activation function. So you can think that for the summation of the w to w and x, w times x, it will be like the part that signal function of x can be x. Okay, so the z1, zh is the summation of weight from ih to times x. So for pi, so can you see if we have pi to be 3 and p2 to be 4, z3 will be the summation of wi h, that is w1 3. Look at this, w1 3 and w2 3. times x1 and x2. So look at this. Signal function of x1 is the input, and we times it to W13. And then plus W23 times signal of x2. This will be the notation that we will use it. And this is the C3, that will be the summation, but we have to add the bias, right? The W0 of node number 3, that is W3 times 1, that is x0, normal x0. So now we have the summation of node P1 already. Or you can think that this one is W dot x, the same way that we did before. This is for Z3, that is the node for P1. P1 will be the node number 3, right? Can you see? Okay. After we got the W dot x, or summation of W0 times 1, W03 times 1, W1 times x1, W2 3 times x2, the signals of x2 or activation of x2, now we will pass it to the sigmoid function, that the normal one. So you can see that we will use Z3 to be the input of the sigmoid function. And then after we sum it and signal it, now it will activate and send the signal to P3 as one input of the P3. It will be the signal function or activation of Z3. That will be the Z3 is a summation, right? I hope that you still remember. And here it will be the signal of the node number 4. So you have to pass the C4 to this activation or signal function of number 4. And both are output from P1, P2 will be the input of P3. After we know the steps from node 3, 4 to 5, number P1, P2 to P3, this one is the part of the hidden. So I move this one down and I will mark it right up to be the hidden layers. And then now we can move to the output layer. So we start from the output layer. The output summation in the hidden layer, I use C to be the output, the summation of the X from the input node. And in output layer, I use Y to denote the summation of the weight from hidden to output. Summation of I0 Q. In this case, we use I from 0 to Q, the number of nodes, the number of input from hidden to output of WH, that is the weight from hidden to output. We start from hidden to output here. So I'll use H to denote the node from hidden and J to be the node in output, and times the signal from hidden of H. After we know the notation, now we will go to the output Y5. The summation in node 5 will be the summation of H from 0 to, we have only 2 links from the hidden, right? So it will be H from 0 to 2 of WH5 times signal of ZH. Okay, that is the output from hidden node. So W5 will be W0 of 5 times 1, that is the x0, right? And w1, no, w1 of 5, and then times signal from z, that is the node from number 1 in the hidden, and I will change it later. W25, that is come from the node number 2 from hidden, times signal of z5, that will that is the node output from the hidden number 2, and then we'll change it from node number 1 in hidden to node number 3, that is the global number, right? Okay, and then W45, that is the input from the link from weight from the node number 4 to node number 5. Finally, we will get the output, the final output, that will be the signal or the activation function of Y5, that will be the sigmoid, right? The sigmoid function of Y5 is, of course, 1 by 1 plus e power minus yj, and yj, of course, this is Y5. So finally, we will get the output, the final output, that will be parsed through the sigmoid function. So this is the end of the forward pass, and then we'll go to the backward pass, that is how can we train the weights of all links in both hidden layer and output layer.